Functions. Let's take a look at an example of a function. F of x equals x squared is an example of a function. This is read f of x. F of x. So practice saying that because pre-calculus algebra is full of functions. Now, functions will not always start with f, but this is the function name or the function notation because the word function starts with the letter f. You are more likely to see f of x rather than c of x, which may stand for cost function, or p of x, which stands for the profit function. Now, what you're used to seeing is y instead of f of x. But did you know that f of x is the same thing as y? Yes, this means that f of x equals y. In the past, you may have worked with y equals some variable or some line like x plus 1. In this case, we have f of x equals x squared. So this is the same thing as y equals x squared. You have an input variable x, which you see on the inside of this function. And y is considered to be your output. So therefore, f of x is considered to be your output. This notation does not mean f of, it does not mean f times x, but f of x. To evaluate a function, all we're simply going to do is replace that input variable or substitute that input variable, or as I like to say, plug it in, or plug in something else for that input variable. For example, we have a function 3x minus 4, and we are going to evaluate this function equals 3x minus 4 for x equals 5. All you need to do to evaluate this function is to replace the x with 5, substitute the x with 5, or plug in 5 for x. So notice we have an x here and an x here. So instead of f of x, we now have f of 5. We're replacing the x's with a 5. So instead of 3 times x, now it's 3 times 5 minus 4. Notice that the left-hand side will stay the same, and usually it's lined up. So you may see this f of 5 lined up. All right, let me put some spaces in between here. So line up the left-hand side if possible. So 3 times 5 is 15, and 15 minus 4 is 11. So your input was 5. You plugged in 5 and got out 11. So your input, again, is your x. That is your input. And here it was 5. And y is your output. And here we got out 11. Again, f of x is the same thing as f of 5 here, right? F of 5 and y are the same. Again, f of x is equal to y. Another point is that if you wanted to create a coordinate point, you have one here, 5, 11, because 5 is your x and 11 is your y. Let's continue using this same function, but let's evaluate this same function f when x equals -3. So again, our function is f of x equals 3 times x minus 4. Therefore, f of what? What are we replacing the x with? -3. F of -3 equals -9 minus 4. Therefore, f of -3 equals -13. We have x equals 0. Let's use the same function. Therefore, we'll have f of 0 equals 3 times 0 minus 4. F of 0 equals 0 minus 4. Therefore, f of 0 equals -4. So, for example, we wanted to another point on this graph. This is a linear function. And we know that because x is to the first power here, we have, if we wanted to graph that line, we have a -3, -13 is a point. But also, in addition, 0, -4 is a point, for example. All right, let's try something different. What if x was equal to w? Well, that would be f of w now, not f of x. 3 times w minus 4. That parenthesis wasn't necessary because 3 times w is 3w. 3w minus 4. What about when x equals 2w? We will have f of 2w now equals 3 times 2w minus 4. Therefore, f of 2w equals 6w minus 4. And what about x equals w plus 1? We have f of w plus 1 equals 3 times w plus 1 minus 4. F of w plus 1 equals, we have to distribute here, 3 times w and 3 times 1. We have 3w plus 3 minus 4. So now we have like terms, as you can see here. Therefore, f of w plus 1 equals 3w minus 1. Let's switch to another function. This function is the g of x function. It is equal to -3x squared plus x minus 1. This is a quadratic function. How do we know? The degree is 2. Degree is the highest exponent. Let's evaluate the function at 0. Therefore, g of 0 equals, we are replacing that x with a 0. All right, in the g of x function. So we have -3 times 0 squared plus another 0 minus 1. G of 0 equals 0 squared here is 0 times that -3 will give us 0. Therefore, g of 0 is equal to -1. What about g of -1? Again, we have -3 times -1 squared plus a -1 minus 1. Again, we have -1 squared because we have to use, please excuse my dear Aunt Sally, which means we have to compute parentheses exponents first before we go off into multiplication and division and addition and subtraction. Negative 3 times negative 1 squared. So that's negative 3 times positive 1 minus 1 minus 1. Therefore, g of negative 1 equals negative 3 minus 1 minus 1. Negative 3 minus 1 is negative 4 minus 1. G of negative 1 equals negative 5. Now this is your opportunity to pause the video. See if you can get g of negative 2 correct without seeing the answer first. So you can pause it now if you would like, work it out, then play the video to see if you were correct. G of negative 2 equals negative 3 times negative 2 squared plus negative 2 minus 1. Again, we need to do parentheses exponents first, negative 2 squared. Therefore, we have negative 3 times positive 4 minus 2 minus 1. G of negative 2 equals negative 12 minus 2 minus 1. So that negative 12 minus 2 will give us negative 14 minus 1. Therefore, g of negative 2 equals negative 15. All right, let's evaluate a piecewise defined function. Piecewise defined functions look like this. Notice there are several pieces to this one function. This function behaves like this, x squared plus 1, when your x's are less than 0. And it behaves like this, x minus 1, when your x's are greater than or equal to 0. So notice that these x values here never overlap on the number line. So you're only going to end up with one answer, one output, because we choose the piece that satisfies that x value. For example, f of negative 1. Here, what is our x? Our x is a negative 1. So if our x is negative 1, we're going to go over here to determine which piece does it satisfy. Is negative 1 less than 0? Or is negative 1 greater than or equal to 0? Since negative 1 is less than 0, we're going to plug it into the first piece, not the second piece. So we have negative 1 squared plus 1. F of negative 1 equals positive 1 plus 1. F of negative 1 equals 2. Let's move on to f of 0. We must ask ourselves, is 0 less than 0? Or is 0 greater than or equal to 0? Since 0 is greater than or equal to 0, we're going to plug it into the second piece here, x minus 1. So f of 0 equals 0 minus 1 because we're replacing the x's with 0. F of 0 equals negative 1. What about f of 1? Which piece, which inequality is satisfied for x equals negative 1? You decide. If you said the second piece, you are correct because 1 is greater than 0. Therefore, we have 1 minus 1, which equals 0. Let's try another one. This is definitely another piecewise defined function. Notice it has 3 different pieces. But again, notice that these numbers do not overlap. This function behaves like 4 minus 5x when the x's are greater than or equal to -2. This function will be 0 if the x's are between -2 and 2, and it behaves as x squared plus 1 if the x values are greater than or equal to 2. Let's look at the table. We have a row of x's. And then we see our f of x. So we need to evaluate each x to figure out what is the f of x. Let's start with x equals -3. If x equals -3, we know that we begin with f of -3. Now, is -3 less than or equal to -2, between -2 and 2, or greater than or equal to 2? Since -3 is less than -2, we will plug in our -3 into the first part of this function. 4 minus 5 times -3. F of -3 equals 4 plus 15. Therefore, f of -3 equals 19. Next, we have 4. Is 4 less than or equal to -2, between -2 and 2, or greater than or equal to 2? Since 4 is greater than 2, we're going to plug in our 4 to the third piece. 4 squared plus 1. F of 4 equals 16 plus 1. F of 4 equals 17. Now, if that number here was negative, I would have put that in parentheses, because a parenthesis versus not having parentheses mean totally different things for negative numbers. If you have a -3 in parentheses squared, that's +9, for example. But if you have a +3 squared, if you have a -3 squared, for example, that's -9. Versus if you had it in a parenthesis, it would be +9. So it's very important that you know when you can not use a parenthesis, and it doesn't matter. All right, here we have -1. -1 is a number that is between -2 and 2 on number line. Therefore, our f of -1 is simply equal to 0. All right, we have a word problem. A cell phone costs $49 a month. The plan includes 500 free minutes and charges 25 cents for each additional minute of usage. The monthly charges are a function of the number of minutes used, given by C of x. So C of x, here we have a case. It's not f of x, but we have a word problem, and C of x must mean something. That C must stand for something, must represent something. I would say it represents the word charges, right? The monthly charges, because of the C. Now it's saying that it's $49 if, what do you think the X represents in this case? If the C represents the monthly charges, the X, it says the monthly charges are a function of the number of minutes. So X must be the number of minutes. All right, now let's find C of 250. So this must mean that someone used 250 minutes. How much would they be charged per month? Well, 250 falls within the first inequality. Therefore, our answer is simply $49. Now, what if someone used up 500 minutes? What would be their monthly charges? Well, they are still within that plan of 500 free minutes, still satisfying that first inequality. Therefore, they must pay $49. But what about C of 665? Now, that person went over their minutes. So 665 is greater than 500. Therefore, we will plug in our 665 into our second piece here. 49 plus 0.25 times 665 minus 500. C of 665 equals 49 plus 0.25 times 665 minus 500 is 165. Now we have 49 plus 0.25 times 165 is 41.25. And that plus 49 charge would be $90.25. Last problem for this video. Evaluate h of x equals x minus 1 for the following. X minus 1 over x plus 3 for the following. Now, what makes this a little different? This is a rational function. It's basically a fraction, right, with variables. So it's a rational function. But please commit to memory what evaluate means. Evaluate again simply means to replace that input variable with something else. Substitute it with something else, or plug something else in for x. And in this first case, we have 0. Therefore, we're going to plug in 0 for x, same as we did before. Therefore, h of 0 equals -1 over 3. Next, we have h of -1. Therefore, we have -1 minus 1 over -1 plus 3. H of -1 equals -1 minus 1 is -2, divided by -1 plus 3 is +2. That can be simplified. -2 divided by 2 is -1. What about h of -3? We're going to plug in -3. -3 minus 1 divided by -3 plus 3. H of -3 equals -4 divided by 0. So what is the conclusion? What is -4 divided by 0? Anyone knows the answer? It is not 0. It is undefined.